Our smartphones know us intimately, through their ability to track our contacts, location, and the content we consume. Though it is best known for its commercial value, this rich data has so much potential for other uses. What if we could use this data in clinical or research study contexts in order to learn more about someone's health? This could be made possible with digital phenotyping, an emerging data collection technique that uses machine learning to quantify the state of a smartphone user. Instead of collecting information about the content they consume, digital phenotyping systems collect data regarding the way users use their device at a granular, more physical level, the way they tap, slide, type, and scroll on their device. Though the technique is still being honed, its potential value in long-term research studies is clear, as it reduces the amount of active effort research participants need to put into the data collection process down to almost none, especially since they are now integrating data from wearable, smartwatches, or other health sensors. Digital phenotyping could be an extremely efficient way of measuring the state of a user's health over time. Digital phenotyping has been successfully implemented in research with younger populations, using smartphone apps such as the open-source, cross-platform MindLamp to collect digital phenotyping data passively and through user-facing questionnaires and tests. However, the Simulation in Digital Health section of the National Research Council is planning a new digital phenotyping research study with a significantly older population to study dementia risk factors. If this digital phenotyping research needs to keep older adult users interested and using the app for the entire length of the study, how might we improve their experience with user-facing health tracking apps to retain engagement? Our project goal is to 1. Make the process of completing a task as easy as possible, and 2. Motivate and encourage the user to participate in the research consistently and continuously. We began by talking to target users to understand how they use health tracking apps in daily life, and what made them want to or not want to keep using them. We also asked them to try using MindLamp to identify potential problems. Combining these findings with design guidelines from literature, we came up with a new concept and interface, got early feedback from an informal test, developed a medium fidelity prototype, and conducted a user test. Our redesign is based on the new conceptual model of a journal, where one records their activity and logs it to access and recall in the future, and thus has been renamed MindJournal. With a brand new app structure, categories of tasks are simplified into a single to-do list of daily tasks. Users can also start a chat with the research team with a single tap and change font size or color themes for better readability. Tapping on the task or on the push notification will directly initiate it. The answer choices are easier to tap and phrased more casually, and the user's current streak is shown upon completion. The user is then taken to a brand new Community tab. This contribution record is meant to invoke their intrinsic motivation for social status and idealism, and this system that features a streak record, point system, progress bar, and contributor levels was our study participants' favorite. The page also shows the number of people who have completed the tasks along you that day, along with a thank you message to create a sense of community and appreciation in a dynamically updated news and tips section, which the research team can use to communicate updates or relevant news items to their participants. Finally, the Data Summary tab is renamed to Report and redesigned to emphasize visually appealing, easily interpretable, and actionable health feedback. Our design was well received in the user tests. Compared to MindLamp, participants took less time to complete key tasks, reported higher ease and satisfaction, and preferred it more overall. We also studied their reactions to different ways to present poor health data and to different contribution or reward systems. Most participants didn't mind negative feedback, as long as it came with actionable steps. And to our surprise, the point-based, level-based contribution system was preferred over the system that used tangible monetary rewards and bonuses for regular participation. As the final deliverables, we proposed to the NRC researchers a fairly refined prototype that was well received by target users. To help them in the next stages of finalizing and implementing the design, we also provide a list of features, each marked by how important it is and how difficult it would be to modify from MindLamp in the report. Beyond the scope of this NRC research on dementia risk factors, we believe our understanding of older adults and design implications could be applied to future digital phenotyping research studies to improve user experience and engagement as well.